Good evening. Good evening, class. So, welcome to Zener Diode Applied Electronics. So, this is a continuation of Zener Diode circuits. So, this is a Zener Diode circuit part 2. Yung first circuits natin last year, tagal na, no? Last year is everything is fixed. So, you have fixed input and fixed RL here. But then, as a review, so what is the usual application of Zener diode? What is the usual application of Zener diode? How is it connected? Is it connected in forward or reverse bias?
Usually reverse bias.
Okay, reverse bias. If it is connected in reverse bias, so what is the voltage across Zener diode? As a review, if it is connected in reverse bias, what is the voltage across Zener diode? If it is on, let's say on siya, what will be the voltage across Zener diode? Equal to? Equal to what? We have what we call V. Ano ba itong VZ na to? Okay. Nakalimutan na. Kalimutan ba? Hello? Hello, hello? Dito pa ba ako? Connected pa ba ako?
Yung
Yes
voltage
po.
po ng Zener diode.
Nakalimutan? Nakalimutan? Okay, let's have a review. Review natin yung topic natin last year. Okay. Hi. Okay, so let's have a recap. Okay. So Zener diode circuit actually works in both forward and reverse bias. So if it is connected in forward bias, so it acts like an ordinary diode, yung rectifier diode ko, di ba? So yung 0.7. So may measure kang 0.7 volts if it is connected in forward bias. However, it also works in reverse bias. So the application of Zener diode is in reverse bias, okay, wherein if it is connected in reverse bias, you should be able to measure a voltage equal to VZ. So pag nag-VZ siya, pag reverse bias siya, there will be reversal in voltage such that VZ mo, yung cathode mo becomes positive and the anode becomes negative. Yan. And these are the usual values. So example lang to. Usual values of Zener voltage. So let's say you have a 3.3 volts here. So you will be given 1N4728A up until 22 volts. So sa sample na to, we have 22 volts. But may mga Zener diode na may higher voltage rating. So these are just an example. Okay. So example here. So this is our example last year. So we have a Zener diode connected in parallel with RL. Okay. Connected in, how is this Zener diode connected? With respect to the supply. So you have a battery here. Reverse of forward bias. How is this Zener diode? Okay, reverse, because positive is connected to the cathode. Okay. So again, if the Zener diode is connected in reverse bias, we expect it to exhibit a voltage equal to Zener voltage. Wherein, pag Zener voltage, this becomes positive, this becomes, while the anode becomes negative. So positive, negative, we say here. But then, we have to make sure that the Zener diode is on. So the voltage across RL should initially be equal to or greater than the Zener voltage. Okay. So let's say, so how we're going to determine if the voltage across RL is enough to turn on the Zener diode. So we do the voltage divider because RL and RS without, okay, so sa analysis to, let's say, wala muna yung Zener diode. So how is RS-RL connected? If ever wala pa yung Zener?
Parallel po.
Series.
Series. With
Series.
respect to RS and RL. Okay. Kasi the reference is with respect to the supply. Okay. So with respect to the supply, kung wala pa yung Zener, so RS and RL are connected in series. Kaya that's why we have a voltage divider here. Kasi sa series circuit class, naghahati-hati yung voltages. Whereas, ano yung constant sa series circuit? Current. Okay, so you have a constant current. Sa series circuit, current is constant whereas voltage naghahati-hati yan. Okay? So, to determine if the voltage across RL is enough to turn on the Zener diode, so take note that in this example, so Zener voltage is equal to 10 volts. So, dapat ang voltage across RL should be at least equal to 10 volts. So, let's say you have a supply here of 16 volts. Okay? RS and RL mo both 1K. So, iti-test natin siya if the voltage across RL is enough to turn on the 10 volts Zener diode. Clear? Okay, so we will use the voltage divider. So voltage divider is RL over RS plus RL kasi numerator natin yan, RL. Kung ano yung hinahanap nating value, voltage across RL times the input. Okay. So basically, since equal yung RS and RL, so hinahati lang natin sa divided by 2 lang actually yung Vin, di ba? Ayan, 16 divided by 2 is equal to 8 volts. Okay, so since 8 volts is less than VZ, so in this example, Zener diode is off. Hindi siya active. Question? Question? Medyo ano pa yung mga, nag-warm up pa, nag-soak pa ba yung brains natin? Question. Okay, class. Okay, clear?
Clear po.
Okay, clear. Okay, so kung the voltage across RL again is less than the Zener voltage, yan, more or less laging given tong VZ. Kagaya niyan, kung paano bibili ka sa tindahan, sasabihin mo, pabili nga ng 3.3 Zener VZ. Zener voltage with 3.3 volts. Given na yan. Ayan. Okay, so for example, number 1, since the voltage across RL is less than the 10 volts VZ, kaya off si Zener. Okay. So what if, anong ginawa natin dito? Yan. Example number 2. For example number 2, tinaasan natin yung value ni RL. Okay? From 1K, it becomes 3 kilo ohms. So, alam naman natin that what is the relationship between voltage and resistance? Voltage and resistance. V is equal to IR, diba? How is voltage and resistance related?
Inversely po.
Inversely ba? V is equal to IR.
Hindi po. Yan. Ano pala? Direct po pala. Direct po.
Okay, directly. No, directly proportional. So, voltage V is equal to IR. So, V is directly proportional with current. V is also directly proportional with resistance. Okay? Pero si I and R, si current and resistance, anong relationship nila? Ayan, si current and resistance, they are inversely proportional. Meaning, kung mataas si current, mababa si resistance. Okay? But the voltage, V is equal to IR, that's Ohm's law. V is directly proportional with current. So, kung mataas si current, mataas si voltage. V is directly proportional with resistance. Kung mataas si voltage, mataas din si resistance. Okay. So that's why, since tinasa natin tong RL here, we expect that there would be a rise in, increase in voltage also across RL. Okay. So hopefully, with the increase of RL to 3K, dapat the voltage across RL should be enough, should be equal to or more than 10 volts VC kasi ito yung target natin, 10 volts VC. Okay? So again, initially, ang pag-solve natin is we disregard the Zener diode first. So tanggalin muna natin siya sa circuit. So if that is so it would appear that RS and RL are connected in series with respect to the input voltage, and by using voltage divider principle, okay, so we have 3K over 1K plus 3K times 16 volts. So voltage across RL now is equal to 12 volts. Okay. Question? Question? Clear?
Clear po.
Okay, clear. Okay, so with voltage, initially with the voltage across RL equal to 12 volts, what do you think is the state of diode? Is it, take note that the VC is only 10 volts, and the voltage across RL initially without that, without Zener would be equal to 12 volts. Would ano kaya state ni Zener? Will it be on or off?
On po.
On na siya kasi ang na-measure natin across RL, so RL would have a voltage as much as 12 volts. Whereas ang requirement lang ni Zener ay 10 volts, okay? So, since VL here is greater than VZ, then VZ is on. Okay? So, take note that this time, alam na natin na on si Zener. Okay? With a Zener voltage of 10 volts. Okay? So, itong voltage divider na to, pang-test lang natin siya kung on or off si Zener diode. Okay? So, since initially VL is 12 volts, so we can be sure that Zener diode is on. Okay? Kasi ang papel ni Zener diode is that pang-cap siya. Pang-cap. Yung voltage can never be greater than, the voltage across Zener diode can never be more than equal to the Zener voltage. So take note that kahit 12 volts, based on your computation, 12 volts dapat ang voltage across RL. And since the Zener diode says that it is only up until 10 volts, hanggang 10 volts lang yan. Ayan. Hanggang 10 volts lang siya. So, ang ma-measure mo dito, since Zener diode and RL are now connected in parallel, kasi alam na natin na on si Zener. So, what do you think will be the voltage across VL?
10
Yung iba? What do you think? Yeah.
10?
10. Okay. Ayan. 10 na rin siya. Kasi Zener and RL are connected in, how are they connected? Parallel. Ayan. Dulo-dulo kasi, di ba? Dulo-dulo connected. Ayan. Ang series kasi, one after another. Di ba? Ano ba to? After ni RS, si RL naman, parang nakapila siya. Pero itong si pag-parallel, yan, dulo-dulo niya connected. Okay? So, yan yung pagkakaiba ni parallel sa series. Yan, dulo-dulo yan. Yan. Okay, so since sa parallel, ano naman ang constant?
Voltage.
Voltage. Tama. Voltage ang constant sa parallel. Since now we're able to we're able to determine that Zener diode is on with Zener voltage of 10 volts. Therefore, the voltage across RL is now equal to na rin siya sa equal na rin siya sa VC or 10 volts. Okay? Kasi kung 10 volts to, dapat 10 volts din siya. Bakit? Bakit ganon?
Parallel po.
Yun, dahil parallel. Okay? Dahil parallel. Okay? Ayan. So, dahil, ayan, okay. So, hindi ko na i-discuss to. I-discuss na natin yun. Ayan. So, meron ang sa parallel circuits naman, ang naghahati ay gaya nito. Ano naghahati? Ano itong mga arrows na to? Current. Yan yung current. Yan. Yung iba dadaan dito, yung iba dadaan dito. Parang kalsada yan eh. Yung mga electricals, yung mga electrical lines, parang kalsada yan. Yan. Yung current, parang tao yan. Tao. Yung voltage naman, yung sasakyan. Siyempre, kung mataas yung voltage, bus yun. Pag maliit, kotse. Mas maliit pa doon, motorsiklo. Mas maliit pa doon, bisikleta na lang, di ba? Yan. Mga ganon. Yan. Ito naman, yan. Pagka maliit lang yung resistance ng kalsada o ng daanan, ibig sabihin, malapad yung kalsada mo. Yan. Makinis yung daan. Yan. Ito naman, pag mas mataas yung resistance mo, makipot, matraffic, maraming lubak-lubak. Ayan. Kaya konti lang ang dadaan na current dito. Diba? Tama ba? Hello? Ayan. Ganyan yung mga analogy, no? Siyempre, alam ba kayo, nagde-drive yung iba sa inyo, saan ba kayo dadaan? Sa maluwag o sa mga traffic na lugar? Siyempre, gusto nyo sa maluwag, diba? Ganun din sa current. So, most of the current will flow through the path or electrical circuit, yung path, electrical path na with least value ng resistance. Kaya nga, the current and the resistance are inversely proportional. So, mas mataas yung resistance, mas maliit yung current. Okay? Yan. So, dito, we have the IS actually is the total current flowing through in the circuit. And then si IS, dalawa yan, pwedeng daanan. Some the current will flow through Zener, some the current will flow through RL. Yan. Pero pagdating dito sa path na to, yung naghiwalay na IC and IL, magsasama ulit sila. They will combine again to become IS. Okay? So, question, hindi ko na masyadong i-discuss to. Ayan. Na-refresh ba? Wala lang nabuluhan. Question. Shall we proceed? Or tapusin natin itong example number 2?
Tapusin po, ma'am. Tapusin na lang, ma'am.
Okay. Sige. Umpisahan ulit natin. Okay. Tapusin natin yung example number 2. Okay. Ayan. So here, we are sure that the Zener diode is on. Okay. So with 10 volts. So therefore, since the Zener is connected in parallel with RL, so we can be sure that VL is also equal to VC. So mag-equal na sila. Again, because they're connected in parallel. Okay? So sa dito, since Zener is on, the circuit becomes a series parallel circuit. Okay? Kasi with RL and Zener connected in parallel, and the combination of Zener and RL in series with RS. Kaya siya series parallel circuit. Okay. And then furthermore, VC is equal to 10 volts since VC connected parallel with RL. Thus, VL is equal to VZ. Yan. Kasi parallel nga sila. So, VZ, with VZ equal to 10 volts, then VL is equal to 10 volts. So, si VL, susunod na siya sa VZ. Kasi si Zener, once it is on, it acts like a supply na rin. Parang na rin siyang DC supply. To compute for IL, we use Ohm's law. Okay. Ohm's law is V is equal to IR, therefore I is equal to V over R. Tama ba? Yan. I is equal to V over R. Voltage over resistance. Okay, therefore IL is equal to VL over RL. So alam natin that VL has become equal to VZ. Kaya we use 10 volts here over 3K. Therefore, the IL is equal to 3.33 milliamperes. So, yung current na magpo-flow through RL is equal to 3.33 milliampere. Next, to compute for IS, find VS first. So, hanapin natin ano ba itong VS. Yan. Madali lang naman, di ba? Kasi, we will have a loop here. Okay? So, this is already 10. 16. So, of course, the difference of that would be equal to 6. Kasi the supply is 16. So, that's the highest voltage. That's the supply. Okay. Minus VS minus VC. With VC equal to 10 and supply of 16. So, VS, the voltage across RS is equal to 6 volts. Okay, 6 volts. Question. Question?
Wala po.
Clear, ma'am.
Here. Ayan. So, VS equal to 6 volts. So, with VS equal to 6 volts, so we can compute for the total current equal to VS over RS. So, 6 volts over 1K. So, we have 6 milliampere. Okay? 6 milliampere. So, we have 6 milliampere here. Ito naman, 3.33 milliampere. Okay? So, medyo nakikita nyo na ilan itong magiging IZ dito. Of course, it would be the difference between IS and IL. However, using Kirchhoff's law, ayan. So, summation of current equal to 0 at the junction, wherein yung mga papasok is positive, palabas is negative. So, base here, so IS minus IC minus IL is equal to 0. Okay? Ayan siya. So therefore, IC is the difference between IS and IL. So we have 6 milliampere minus 3.33 milliampere. So we have IC of 2.67 milliampere. Okay? And then we have with Iyat ako dito. 2.67. With IZ equal to 2.67, and to solve for PZ or the power consumed by the Zener Diode, so we will use power formula. VZ power is equal to VZ VI or VZ IZ. So the Zener voltage is 10 volts times the current consumed by the Zener. We have 2.67 milliampere. So the product is equal to 26.67 milliwatt, which is less than the PZM rating. So we have to look out for the PZM rating. Okay?
Ma'am, wala po na tayong shared screen.
Nawala. Sorry. Wala. Okay. Dito ba ako nawala?
Okay na po.
Okay. So again, IC is 2.67. Yan. Kasi it is IC is equal to IS minus IL. IS natin kanina is 6 minus 3.33. So IC is 2.67 milliampere. And then to compute for the actual power consumed by Zener, so we'll use the power formula. P is equal to VI. So we have 10 volts times 2.67 milliampere. So the actual power consumed by the Zener is 26.67 milliwatt. Okay, which is less than the PCM. So it should always be less than PCM. So ideally, dapat half lang. Okay, half lang dapat ng rating. So kung 26 to, dapat mga 50 something tong milliwatt mo, di ba? Otherwise, pag masyado ka na malapit sa rating ng ito, 30 milliwatt, mainit masyado yung magiging mainit mo. It manifests as a heat. Kaya 'di ba minsan yung mga resistor mainit pag hinahawakan. Okay. Yung power dissipation. Okay. But then, nevertheless, this is still less than PCM, 30 milliwatts. Dapat hindi pa sasabog tong ano mo, yung Zener mo. So, ano ba mangyayari if you reach the maximum or exceeded the maximum yan? Magkakaroon ka na ng failure sa device. Sa electronics, di naman masyadong delikado. Kahit sumabog siya, hindi sa experiment, wag lang sa actual. Ang mahirap ng pag nakakabit na sa, let's say, sa mga automotive or sa mga pang-healthcare, yun, delikado yun, ano, sa aeroplano. Yan. Sa experiment, pag napuputokan ka ng device, okay lang. Yan. Nakagulat lang. Ayan. Ayan pa lang. Okay? So, next is, ito, yung hindi ko nagawa nung last time. Okay? Let's continue. Question pala, question. So, fix RL. Question. 19. Clear na? Let's proceed with okay, shall we proceed with the part 2 of Zener Diode?
Yes po.
Okay. So, this is fixed V in and variable RL. So, ito, na-adjust na natin yung RL. Okay? So, we may use potentiometer. Pwede natin gamitin potentiometer sa RL para magalaw-galaw natin, mabago-bago natin yung resistance. Let's say you have an RL of 1 mega ohm. Ano ba lang, 1 mega ohm yung value ni RL. So, meaning that, pwede mong baguhin yung resistance nga from 0 to 1 mega ohm. I-adjust mo siya. Iniikot-ikot. Okay? Potentiometer. Is this your first time na mag-electronics?
Yes po.
Yes po.
Kahit sa tech?
Yes po.
Okay. Sige. Ayan. Okay. So, with fixed V in and variable RL, so hahanapin natin yung value ng RL such that the Zener diode will be on. Okay? So, para mag-on si Zener, dapat ang voltage across RL should be at least equal to VZ. So, dapat ang value ni RL should be at least equal to, voltage across RL should be at least equal to 10 volts. Tama ba?
Yes, ma'am.
Yes.
Okay. So, yun ang hahanapin natin. So, para magawa natin yun, so we have a, what's this? Voltage divider. Ito yung ginagamit natin kanina, di ba? So, to determine if the Zener diode is on. But then, in this fixed V and variable RL, the premise is that the Zener diode is already on. So, to do so, dapat si VL should be equal to VZ. Tama? Hello?
Yes, ma'am.
Yes po.
Okay, so we're actually using the same formula. Same voltage divider principle. So, ang VL mo dito, dapat equal siya sa VZ para sure tayo na on si VZ. Okay? Now, ito yon. Okay? So, ang VZ natin should be equal to VL. Okay? So, ito yung paano natin siya, hindi ko na-discuss. Yan. Ano nang dulo na? Okay, so RL mean. RL mean is equal to VZ RS over V in minus VZ. So, yun yung naging summary niya. Okay? Yung mga nauna yun, yung details on how it arrived in this formula. So, RL means equal to VZ RS over V in minus VZ. Okay? So, paano natin, we'll just supply the values here. May mga value naman tayo given si VZ, given si RS, and a V in and VZ. So, RL mean is 10 volts times 1K over 50 minus 10 volts. So, we have supply of 50 volts. So, therefore, this would be equal to 10 over 40. Okay? 10 over 40, 10 times 1K over 40 volts is actually equal to 250 ohms. Tama ba? Verify nyo sa calculator nyo. Tama ba? Tama? 250 ohms. 10 times 1K. What is K? That's times 10 to the 3 raised to 3. 10 raised to positive 3 over 40 volts. Is it equal to 250 ohms? Can you verify?
Yes, ma'am. Tama naman po.
Okay. So, we have 250 ohms. So, the minimum value of RL to turn on Zener should be set to 250 ohms. Okay. So, therefore, the maximum current, if RL is set at 250 ohms, so by Ohm's law, this is just simply equal to Ohm's law. I is equal to V over R. Kasi Ohm's law is V is equal to IR. Okay. Familiar naman kayo kay Ohm's law? That is basic electrical circuits.
Yes po.
Okay.
Yes po.
Okay, so V is equal to IR. So therefore, I is equal to V over R. So if RL mean is 250 ohms, so the current flowing through RL would be equal to 40 milliampere. Ayan. Can you take note? If you have minimum RL, you'll have maximum current. Kasi nga, the relationship between resistance and current are, ano relationship nilang dalawa?
Inverse po.
Inversely proportional. Okay, so you have maximum current here. If it is set at 250 ohms, so you'll have 40 milliampere. Okay, and then the IS, okay, so ganun pa rin, IS, so we'll have a loop here. And using summation voltage is equal to 0, KVL at loop 1. So we have 50 minus VS minus VZ is equal to 0. So we have V in 50 minus VS minus 10. So we'll have VS of 40 volts. So IS is 40 volts, 40 milliampere. 40 milliampere also for IS. So although that Zener is already on 10 volts, so parang ka-on pa lang siya. So IC is at minimum. So approximately equal to 0. But in reality, it's not really 0, no? So this is just for simplification of computation. Yeah, for simplified approach. So at minimum value, parang ka-on pa lang na, no? Ka-on pa lang yung Zener. So approximately 0 na pa-flow na. Almost near yung current na na-flow through Zener. Okay? Okay, so, ayan, nakuha na natin si RL mean. Now, it's time to determine RL max. To determine RL max, what is the maximum resistance na pwede kay RL na hindi naman puputok si Zener Diode. Actually, hindi pa ako nakakitang may pumutok na diode. Matibay talaga ang mga diodes. May nakita na akong pumutok na capacitor IC. Nasunog na resistor pero hindi pa ng diode. Ayun. So what is the maximum value of RL max such that you have to consider the IC max rating of 32 milliamperes. So this time the given is the IZM. Okay. So to determine RL max, we have to determine IL min first. So hanapin na muna natin yung minimum current flowing through RL max. So to determine IL min, okay, so we must using KCL at junction A. Ito, di ba? Remember kanina? So we have KCL, summation current at junction A, okay, such that current in minus current out is equal to 0. So ano ba yung current in? Pag sabing current in, yung mga arrow papasok sa junction. Yan, current in yan. Okay? Current out, palayo. Yan, palayo. Current in natin is IS minus IC minus IL is equal to 0. Okay? So, IS is always at 40 milliampere. Hindi naman nagbabago. Hindi naman kasi nagbabago si VS. Okay? Ang magbabago is the current flowing through Zener and RL. So this time nahanap natin ano kaya ang minimum IL dito such that we can determine the maximum RL. So remember what is the relationship between resistance and current?
Inverse po.
Inversely proportional. Okay, kaya we have minimum current here, minimum IL, maximum RL. Okay? So we will only have minimum IL if the current flowing through Zener is at maximum. Okay? Which is given tong ICM at 32 milliampere. Ito yung nasa specs. Ayan, parang PCM. Ayan, 32 milliampere. So the input is 40 milliampere and most of the current already go through Zener at 32 milliampere. Of course, ang dumaan na lang kay RL is 8 milliampere. Yan, yun na lang yung natira. Okay? Yan. So, IL min is equal to 40 milliampere minus 32 milliampere is equal to 8 milliampere. So, that's the minimum load current flowing through RL. So, with IL min is equal to 8 milliampere, anong kasunod? Paano natin malalaman si RL? Anong formula gagamitin natin? Meron kang voltage, meron kang current. How are we going to determine the resistance?
Voltage divided by S.
Anong tawag natin sa formula yon?
Ohms.
Okay, so we'll use Ohm's law. Yan, napakagamit na gamit ni Ohm's law. Yan, basic pero gamit na gamit. Yan. Talagang dapat you should never forget the basic. Ayan. V over I. V is equal to IR, so therefore R is equal to V over I. Ayan. We have 10 volts over 8 milliampere, so RL max is 1.25 kilo ohms. Ayan. So therefore, pwede natin pihitin si potentiometer from 250 to 1.25K. Pag in-exceed nyo pa si RL sa 1.25, pwede nang masira ang Zener Diode nyo. Kasi as you increases the RL here, ano mangyayari kay IL?
Magdadrop.
Lalong liliit, di ba? Pag lalong lumiit si IL, ano mangyayari sa current flowing through Zener?
Mataas po.
Lalo lalaki. Ayan. Kasi ang total nitong dalawa, IZ and IL is equal to 40. Siyempre, kung mas mahirap dumaan sa RL, dito siya dadaan. Yan. Kaya lang, may maximum siya, 32 milliampere lang. Diba? Kaya pag tinaasan nyo pa si RL, more than 1.25K, so masisira na ang inyong Zener. Okay. Ayan. Question. Question? Clear?
Clear po.
Okay na? Okay.
Yes po.
Okay, so last topic na tayo ngayon for tonight. Okay. Variable, please don't be shy, no? Don't be shy to ask questions, no? I understand, yan, kung medyo mind-boggling, yeah, especially kasi talagang, ever since I arrived at BN, mga students ko naman talaga is electronics, civil, architecture, chem, mechanical, so lahat yan wala pang background sa electronics. Okay? So that's why my approach is as elementary as possible, as simple as possible. Okay. Any question? None? So proceed tayo. So, by the way, but then, lagi na tatandaan, no? Ano bang mga formula yung gamit na gamit natin so far?
Ohm's law po.
Ohm's law. Ano pa?
Kirchhoff's.
Yan.
Kirchhoff's.
Kirchhoff's, diba? KVL, KCL. Yan. Diyan lang naman tayo halos naglalaro. Ano? Minsan nag-introduce ako ng voltage divider, but then actually voltage divider is also based on series circuits. Series circuits din. Okay. So far, can you track, nasundan nyo naman yung Ohm's law, KVL and KCL, mga loopings natin and junctions.
Yes po.
Opo.
Okay. So far, okay naman. Okay, so let's proceed with, so this will be our last topic for tonight. And then after this, you may enjoy your dinner. Okay, variable V in and fixed RL. Okay. So this time, ito namang input ang hinahanap natin. Okay. So, actually, ano ba itong variable input na ito? Potentiometer. Parang may isa-set din tayong potentiometer such that we'll have variable supply. But then, for our experiment, so I will design an activity for this. Hindi na natin siguro magagawa itong variable input, but rather the first two lang. Okay? So we have actually 3 circuits. This is the third one. Fixed input and fixed RL. Yung second natin, yung kanina lang, is fixed input and variable RL. Ito yung third, variable input and fixed RL. Hindi na natin magagawa ito sa activity because wala naman kayong variable supply sa bahay. But then, ito, tingin ko magagawin nyo ng paraan, potentiometer yan. May nabibili niyan, mga around 25 pesos. Pag masyadong mahal, Yan, kaya lang. Okay, so we have variable input and fixed RL. So this time, ito naman ang hinahanap natin. So ito pa rin, ano ba tawag natin sa formulang ito? VL is equal to RL over RS plus RL times V in. Ano tawag natin sa formulang ito? Hello? Ang tawag natin sa formulang yon? Ang tawag natin sa formulang to, class? VL is equal to RL over RS plus RL over times V in.
Voltage divider.
Ayan, voltage divider. So we call it voltage divider principle. Okay, ito pa rin. VL is equal to RL over RS plus RL times VA. Okay. So, if, yan. So, dapat, ang masatisfy pa rin natin that the VL, voltage across RL, should be at least equal to VJ to turn on. This time, we have VJ of 20 volts, IZM of 60 milliampere, RS 220 ohms, and RL of 1.2K. So, dapat sufficient enough yung VIN natin to turn on the VJ. So, ito naman yung nahanap natin, itong value na to ng VIN. Okay? So, dapat to turn on VJ, dapat ang VL natin should be equal to VJ. So, let's see on the next slide. Okay? So, since VL is equal to VJ, yan. VJ is equal to RL over RS plus RL times VIN. Ito yung nahanap natin. VIN min. Okay? So, the minimum input, okay, would be equal to VJ times RS plus RL over RL. Pinapalit lang natin, no? This is the denominator becomes the numerator, and then numerator becomes denominator. Nilipat lang sa kabila. So, the minimum input voltage would be equal to, so 20 volts times 220 ohms plus 1.2K over 1.2K. So, 220 plus 1.2 over 1.2. So, we have input voltage of 23.67 volts. So, that's the minimum required input for VIN. Okay. How about the maximum? So, the minimum maximum determine what is the maximum IS. Ano kaya maximum current flowing through RS? Okay. So, to determine the maximum IS flowing through RS, so we must consider the IZM value ng VC. So, IZM plus IL. So, that would be the maximum current flowing through RS. And the IZM is 60 milliampere, whereas, paano natin makukuha si IL? Paano natin makukuha si IL? Anong gagawin natin? Hello?
RL over B.
Okay, so we will use V over IR. So current is equal to, again,
Ma'am, RL po over VL po ba?
baliktad. Yan.
IVR.
V over R. Okay, V over R. Kasi V is equal to IR. V is equal to IR. So, current is equal to V over R. Okay, Ohm's law. Okay, so we have current is using Ohm's law pa rin. V over R, so 20 over 1.2K is equal to 16.67 milliampere. So, kung may 16.67 milliampere ka, may 60 milliampere ka, so therefore, the total, the maximum current flowing through RS would be equal to 76.67 milliampere. Okay? Question? Question? Clear? Paano naging 76 to? So, magkakaroon tayo dito ng junction. Tama ba? Yan, junction. So, we'll have a junction here such that summation of current is equal to 0. So, we have IS minus IZ minus IL is equal to 0. Okay, and therefore, IS equal to IZ plus IL. Okay. With IZ of 60 milliampere given, okay, IL of 16.67, ito yung kanina, So we'll have a maximum current flow to R is equal to 76 milliampere. Question. Question? Clear? Is it clear? Okay lang? Okay. Ayan. So, we have, okay. So, Vn max is equal to, so, summation voltage here. So, we can have a loop here. Vin minus Vs minus Vz is equal to 0. So, therefore, Vin max is equal to Vs plus Vz. With IRS max equal to 76.67 times 220 ohms plus 20 volts. So, we shall have a maximum of 36.87 volts. So, pag ang maximum, pag ang input voltage mo exceeds 36.87 volts, so pwede nang masira si Zener Diode. Kasi it is beyond na siya sa ICM niya na 60 milliampere. Mag-exceed na siya dyan. Question. So, this is the last slide. You have any question, class? Clear ba? Can we have the attendance now? Turn on your cam, please. Oh, may mag-open ba ang cam? Parang may kulang pa. Wala na. Okay. Ito si Kenneth. Tama ba? Aga mo Si Glory. Hindi mag-on? Lagi nag-on.
Ma'am, naka-on na po.
Ayan, nakita. Hindi na kita napansin. Okay, so 5, 4, 3, 2, smile. Ayan. Sa Friday, exam natin. Isa pa. Ayan. Hindi ko na maximize yung space. Yeah, 5, 4, 3, smile. Yeah. Okay. So, sa Friday, exam pa rin tayo. Pero magle-lecture muna ako, ha? Okay, lecture and then I will upload the exam. Yan. Dalawa lang naman yung topic natin doon. Ano yung topics natin? Zener and... Nakalimutan ko. Rectifier. Tama ba? Rectifier. Ayan. Madami-dami din pala. Rectifier, half wave, full wave, and Zener Diode circuit. So, at least 5 circuits pa yun, ano. Anyway, ang half wave, dalawa lang, di ba? Positive, negative, half wave rectifiers. For full wave, dalawa din, bridge type and center top. Okay? And then sa Zener, tatlo. Yan, tatlong circuits. Yan. So, again, you only have 1 hour. And then, mag-upload din ako ng activity for Zener Diode and then lecture tayo ng transistor. So, we have to introduce the transistor na sa Friday kasi next week, circuits naman for transistor. And then, on the 3rd week, starting January 18, term test nyo na. Yan. Aware ba kayo na term test nyo na starting January 18? Hindi ko yata. Term test nyo na. Ayan. So, kung may mga utang pa kayo sa mga ibang subjects, yan, kailangan nyo nang bunuin. Okay? So, if you have any, may mga questions pa ba? Wala na? So,
Ma'am, madi-discuss po ba sa amin yung mga scores namin sa exam?
hindi ko pa na, na-check. Check ko ngayong week.
Okay po, ma'am.
Kasi, nahilo ako nung bakasyon. Hindi ako nakapagbakasyon. Nahilo lang ako. Ano bang hilo yun? Oo. Sige. This
Thank you,
week, actually, yun talaga yung nakaschedule sa akin ng bakasyon. Kaya, na-detect ko agad yung lindol ng December 25. Ayan. Malakas din ba lindol sa inyo? Malakas no?
Naramdaman, ma'am.
Yes.
Malakas!
Hindi ramdam, ma'am. Lasing po kasi.
Hindi po ramdam.
Aga-aga lasing. Ang lakas at ang
Galing po
tagal
ng 24, ma'am, kaya lasing pa.
Ang lakas at ang tagal niya. Kaya nahihilo nga ako nun. Kaya parang hindi ko nga alam kung hilo yun. Gumalaw na yung ilaw, yung pinto namin, na. Nagbabang-bang na. Kaya, hindi ko lumilindol. Malakas siya actually. Malakas yung dating dito sa amin. Ayan. So, kung wala nang tanong, hanggang dito na lang. So, enjoy your dinner and bye. Goal ko yan ngayong week, yung mga scores. Okay, bye-bye.
Thank you, ma'am.
Thank you.
Thank you po.
Thank you po.
God bless po. God bless.
Thank you po.
Okay, bye-bye.
Bye-bye po.
Thank you po.
Thank you po, ma'am.
Bye-bye po.